Hey everyone. So, real talk. Newton's laws can feel a little, dry in the textbooks, right? But what if I told you they're basically the secret code for everything around us, from a perfect cricket shot to a rocket launching into space? Okay, let's actually make sense of this.
Think about it for a second. You've felt this your entire life. The bus driver hits the brakes and whoosh, you lurch forward. Or you lean on a wall with all your might and nothing. It doesn't budge. These aren't just random little quirks of life. This is pure physics in action. And today, we're going to unlock exactly why this stuff happens.
Now, if you've ever felt that physics is just broken or super confusing, I totally get it. You're not alone. But listen, the problem isn't you. It's the way we're often taught. Textbooks just throw these heavy, complicated definitions at us with zero real-world context.
I mean, seriously, look at this. What are you even supposed to do with that sentence? Yeah, it's technically correct, but it doesn't feel real, does it? It just sits there on the page, completely disconnected from the world you and I actually live in.
Sound familiar? Yeah, we've all been there. You cram it, you memorize it for the exam, you write it down, and then poof, it's gone a week later. It feels like it never sticks because our brains can't link this abstract rule to anything we can actually see or feel. And this is that frustrating cycle we all get trapped in. But today, we're breaking that cycle for good. We're going to stop just reading about physics and start seeing it absolutely everywhere. So let's start with the first law and make it something you'll actually remember. Okay, so here's the first cheat code. Forget Newton's first law. From now on, we're calling it the law of laziness. Because honestly, that's all it is. In the world of physics, objects are just incredibly lazy. They want to keep doing whatever it is they're already doing. So here's that formal definition again, but don't you dare try to memorize it. Just grab the main idea. Things want to keep doing what they're doing unless something from the outside comes and messes with them. This is it. This is the whole idea. If an object is still, it wants to stay still. If it's moving, it wants to keep moving in the exact same direction at the exact same speed. It takes an outside push or a pull, what we call a force, to change its lazy state. Simple as that. Now let's go back to that bus. You and the bus are moving forward together. Then the bus stops. The brakes are the external force on the bus. But for that split second, no force has acted on you yet. Your body, being lazy, just wants to keep moving forward. That resistance to change, that is inertia. And here's a huge misconception a lot of people have. A ball rolling on the ground doesn't just get tired and stop. No way. It stops because of an invisible external force called friction. The ground is constantly pushing back on it. If you were in space with no friction, that ball would literally just keep going forever. All right, you ready for law number 2? Let's call this one force equals fun. Now, I know formulas can look a bit scary, but trust me, F equals ma is where all the action happens. It's basically the engine that runs the entire universe of motion. Okay, so the textbook hits you with this. The acceleration is directly proportional to the net force and inversely proportional to its mass. I know, that's a total mouthful, but I promise you the idea behind it is something you already understand perfectly. And here it is. This is all F equals m is really saying. Seriously. The harder you push something, that's more force. The faster it speeds up, that's more acceleration. And if something is really heavy, that's more mass. It's way harder to get it to speed up. You know this from just living your life. Just picture this. Imagine pushing a bicycle with all your might. With its small mass, it just zips forward, right? High acceleration. Now use that exact same push on a car. The car, it barely even budges. Same force, but the huge mass results in a tiny, tiny bit of acceleration. So this is our second cheat code. This simple relationship is everything. It's why a fast bowler uses their whole body to generate massive force, to make the ball accelerate like a rocket. And it's why racing engineers are obsessed with making cars super light. Less mass means way more acceleration from the same engine. And now for the third and final law. This one's my personal favorite. Let's call it the cosmic pushback. This one sounds simple on the surface, but I promise you, when you really get it, you will see the entire world differently. It's pretty mind-blowing. So we've all heard this a million times, right? For every action, there is an equal and opposite reaction. But what does that actually mean? Let that sink in for just a moment. Here's the secret. This is the third cheat code. The universe has a strict, unbreakable rule. There's no such thing as a one-sided push or pull.
When you push on a wall, that wall is always, without exception, pushing back on you with the exact same amount of force. Always. Now check this out. How do you walk? It seems so simple, but it's pure Newton's third law. Your foot pushes the ground backward. That's the action. In response, the ground pushes your foot forward. That's the reaction. You are literally pushing the entire planet Earth away from you just so you can take one step. How cool is that?
Okay, pay attention because this is the part that trips up almost everyone. This is crucial. People always ask, if the forces are equal and opposite, why doesn't everything just cancel out? It's because the forces act on different objects. Your push acts on the Earth. The Earth's push acts on you. Since they're acting on different things, they don't cancel out.
Okay, so now you have the cheat codes. You get the laws in a way that actually makes sense. So the big question is, how do we make this knowledge stick? How do you turn this into a real physics superpower that you can actually use in your exams and in life? Let me show you. Here's a simple, powerful 3-week plan. Week 1, just observe. That's it. Be a physics detective. Spot these laws happening around you. Week 2, open up the textbook and practice some problems. And week 3, the final boss level, teach it. If you can explain these laws to a friend using these simple examples, you've officially mastered it. And let me give you one final pro tip, a little secret that's going to make solving those numerical problems 10 times easier. Always, and I mean always, draw a free body diagram. It's just a simple sketch of the object with arrows showing all the forces acting on it. I'm telling you, if you can see the forces, you can solve the problem. You've totally got this. You now have the real-life cheat sheet to see the world like a physicist. It's not about memorizing, it's about seeing and understanding. So what should we break down next? Gravitation? The work-energy theorem? Let me know what you're struggling with or just curious about in the comments below. Let's keep learning.